Hi, this is Mrs. Boland with the University of West Florida, teaching section 6.6 of our college algebra series. Welcome to class. The first thing I want you to do before we get started is make sure that you have your pencil and paper and a calculator, because today you're going to be using your calculator a good bit to solve logarithmic equations. So if you don't have your calculator yet, just pause the video, go find it, and then come on back. So now I assume that everybody's ready to go and we're going to get busy. Of all the sections that we have presented so far out of chapter or mod 6, this section here has probably the largest portion of problems coming from on your next exam. This is the more complex problems. We're taking everything we've learned so far in mod 6 and applying it and using different techniques in this section. So please pay attention, rewind the video if you need to, watch it a couple of times, reach out to your UWF instructor and ask questions if you don't understand something, because this material here not only will you see on your next exam, but also on the final exam. And you'll see a number of problems from this section on both of those exams. Alrighty, so now that you're ready to get learning, let's get started. So the first thing we're going to do is we're going to talk about exponential and logarithmic functions and review a little bit some of the basic rules of what we know concerning exponentials. So solving an exponential equation using the properties of exponents. Okay, that's where we're going to start off. We have a property of exponents, and it says if we have a raised to the b and that equals a to the c, then b must equal c. And that is very true. Just think about it. If I have the same base, 2 and 2, and they're raised to an exponent, the exponents, if this is 4, this must be 4 if they are indeed equal, correct? Okay, so it can't be any other way. 4 would have to equal 4. That's all we're saying right here. So the objective here is to rewrite a problem to the same base. We've already kind of worked on that in some of the other sections, but we're going to be working on that a little bit more here. So the question becomes, how can I rewrite 36 to base 6? I have to have a common base. 36 is equal to 6 squared, 6 times 6, correct? So I can rewrite 36 as 6 squared. So I can say this is 6 to the negative 2x, and that is equal to 6 squared. Then I have to put this other exponent, 4, right like that. Okay. Now, following our rules of exponents, we know that this exponent, which is raised to this exponent, will be multiplied. So that means 6 squared to the 4th power is the exact same thing as 6 to the 8th. Well, let's just take and prove that real quick. 6 squared to the 4th power. 6 squared is 36. 36 to the 4th power, let me grab my calculator because I don't know that one off the top of my head, is a large number. It is equal to 1679616. So we'll put my commas in. So that's 1,679,616. Let's look at what 6 to the 8th power is. Grab your calculator, practice with me. 6 raised to the 8th power, guess what, is the exact same number. It's 1,679,616. So I just proved to you that this statement right here is actually equal to this statement right here by doing the mathematical calculations. Now that I know that, I can continue on, and I can say then that 6 to the negative 2x is equal to 6 to the 8. Okay? If I have 6 to the negative 2x equals 6 to the 8th, if these are indeed equal statements, that tells me then that negative 2x must equal 8. This must equal this for that to be a true statement. I have an equation here that we all know how to solve. All I have to do now is solve for x. I have a -2 that is multiplied by x. I separate the multiplication using division. I divide both sides through by -2, and I get therefore x is equal to -4. Let's just go ahead and check our work just to prove to you that this worked. So my answer is right there, okay, that x is equal to -4. But let's do a check. If I have 6 to the -2 times x, which is -4, does that equal 36 to the 4th? That is my question that I'm asking. Well, 6 to the -2 times -4 is to the 8th. So 6 to the 8th, does that equal 36 to the 4th? We already proved that it did, because right here I said 36 to the 4th is equal to 1,679,616. And I proved right here that 6 to the 8th is 1,679,616. So yes, I know that those two are equal. So x equals -4 is the correct solution for this problem. Let's look at number 2. Number 2 says 32 to the x plus 1 is equal to 16 to the 1 minus x. My objective is to get these to the same base. I can't get a 32 to base 16, so I'm going to look further. What other common bases might they have in common? How about base 2? Because 2 raised to the 0 is 1. 2 to the 1 is 2. 2 squared is 4. 2 cubed is 8. 2 to the 4th is 16. 2 to the 5th is 32. So I can make this and this side both base 2, and then I will have the same base. Once I have the same base, I can let the exponents equal each other and solve for x. So 32 is the same thing as 2 to the 5th. So I'm going to put 2 to the 5th, and I'm going to raise that to the x plus 1. So x plus 1 is equal to 2 to the 4th. 2 to the 4th times 1 minus x. An exponent raised to an exponent, they are multiplied by each other. I have the same base, so this could be rewritten like this. This could be rewritten as 2 to the 5th times x plus 1, because I'm going to multiply my exponents, because it's one exponent raised to the other, so it's multiplication, is equal to 2 to the 4th times 1 minus x. Again, because it's 4 raised to an exponent, we're going to multiply the two exponents together, and so that's all I wrote right there is the multiplication. I have the same base, they're equal, therefore I know this exponent must equal this exponent. Well, let's just write that down then. So it's 5 times x plus 1 is equal to 4 times 1 minus x. We're now going to distribute the 5 into the parentheses and the 4 into this set of parentheses. So I get 5x plus 5 is equal to 4 minus 4x. Solving for x, we're going to add 4x to both sides, subtract 5 from both sides, and we're going to get 9x is equal to 4 minus 5, -1. Divide both sides through by -9, and I get therefore x is equal to -1/9. And that is my answer. If we want to plug it in and check it, you can do that and you will see that it is the right answer. Let's review our properties of logarithms. If I have log base b to the bx, that is equal to x. Let's apply that to the example here. We have log of 10 to the 2x equals 2x. This is log base 10, so this is log base 10 of 10 to the 2x is equal to 2x. If I rewrite this as an exponential, it's going to be 10 to the 2x is equal 10 to the 2x. And then I know 2x must equal 2x following the logs of the exponents, right? So 2x must equal 2x. Let's look at this one here. This is the natural log. So if I have the natural log, that's the same thing as log base e. So this is log base e of e to the 0.5 t is equal to 0.5 t. Working in our circle here, going here to rewrite as an exponent, that's going to be e to the 0.5 t is equal to e to the 0.5 t. Therefore, 0.5 t must equal 0.5 t. We're going to use these properties right here for our next few examples to solve. Step 1 of solving these problems right here is take the log of both sides. Step 2, solve for x. After applying the power rule. Okay, so we're going to apply the power rule after we take the log of both sides. So step 1, take the log of both sides. So it's going to be log base 10 of 10 to the x is going to be equal to the log of 9.37. That was step 1. Now I'm going to apply the power rule. So step 2 probably should be apply the power rule, and then step 3 should be solve for x. So next we're going to do the power rule, which is x is going to be brought out front here. So I have x log 10 is equal to log 9.37. Now I need to solve for x. In order to solve for x, I'm going to have to solve or divide both sides through by log 10. That'll get x by itself. So take this and just kind of come over here. I'll rewrite it. X log, I'll try to rewrite it, 10 is equal to log 9.37. We're going to divide both sides through by log 10, log 10. Now that crosses off, therefore x is equal to log 9.37 divided by log 10. Grab your calculators, punch it in, and you should find that it is equal to 0.9717. Again, grab your calculators. Don't just watch me write it down. You go ahead and do the calculations and make sure you get the right answer, please. If you did the calculation on this problem right here and you got the right answer right there that was circled, email or text your instructor the code word PEACH, P-E-A-C-H. The code word is PEACH. Looking at problem 4. Step 1 again is going to be taking the log of both sides. When you see an e and you're going to be taking the log of an exponential and it actually has e in it like this, take the natural log because you need the same base. It helps out a little bit, okay? So we're going to take the natural log of e to the x is equal to the natural log of 17.45. Step 2, we're going to let that be the power rule. Apply the power rule, so that's going to be x natural log of e is equal to the natural log of 17.45. Step 3, solve for x. So I have x natural log of e is equal to the natural log of 17.45 to solve for x. This is just a number. This is like a coefficient. So you can divide both sides through by the log or the natural log of e. Natural log of e. Let's look real quick again at the natural log of e. So if I have the natural log of e, that is equal to log base e of e. If I set that equal to x and rewrite this right here as an exponential, it will be e to the x equals e. So e to the x equals e. What must x equal to make this a true statement? It must equal 1, right? So therefore, x equals 1. If x equals 1, and 1 then would equal log base e of e, which would also equal the natural log of e. Thus, natural log of e equals 1. So all I'm doing right here is dividing through by the number 1. Very important for you to recognize that. So this is equal to the log of 17.45. Therefore, x is going to be equal to, get out your calculators, punch it in. Punch in 17.45, take the log of it, and you are going to see that that should equal something around 2.8593 right there. Okay? Again, get out your calculator, work along with us. Make sure you understand that the natural log of e actually equals 1. So right here, I'm just dividing through by the number 1, which is why I can just simply say x is then equal to the natural log of 17.4. Number 5. The first thing we want to do is make sure that we have just an exponential on the left-hand side of the equation. In order to do that, we're going to add 6 to both sides. I now have 4 times 10 to the x is equal to 13 plus 6 is 19. I still don't have the exponential by itself though. I need to divide both sides through by 4 to have that. So now I have 10 to the x is equal to 19 fourths. Now I have an exponential equaling a number. I can take the log of both sides. So taking the log of both sides, I have log 10 to the x is equal to log 19 divided by 4. Apply the power rule. X log 10 is equal to log of 19 divided by 4. Divide both sides through by log 10. Therefore, x is equal to, that goes away, I have log of 19 divided by 4 divided by log 10. Get out your calculators, punch it in. Hopefully, you found that it is equal to 0.6767. If you did, please email or text your UWF instructor the code word PURPLE. If you did not get that calculation correct and you're still having struggles with your calculator, please email or text your UWF instructor the code word YELLOW. Number 6. Again, the first thing we want to do is get this exponential isolated by itself before we take the log of both sides. So I'm going to subtract 12.34 12.34, subtract from both sides. I get negative 2.64. E to the x is equal to negative 1.69. I still don't have my exponential by itself. I have this negative 2.64. It's connected through multiplication. To undo multiplication, I'm going to use division. What I do to one side, I must do to the other side of the equation. Therefore, I have e to the x is equal to negative 1.69 divided by negative 2.64. You'll see that you can go ahead and convert this to a decimal, and then that is going to be equal to a positive negative divided by negative 0.6402. So now I'm going to take the log of both sides because I have an exponential here and a number here. Because I have e to the x, I'm going to take the natural log of both sides. One of the things you want to key in on is when you're dealing with the exponential, the letter or the number e, you want to take and go ahead and use the natural log. So we're going to take the natural log of e to the x, and that is going to be equal to the natural log of 0.6402. That's step 1. Step 2, we're going to apply the power rule. So that's x natural log of e is equal to the natural log of 0.6402. Remember that the natural log of e is just equal to 1. So we could go ahead on step 3, we're solving for x. We could go ahead and just say x is equal to this, or you can go ahead and divide through by the natural log of e. But it is just 1. So we can go ahead then and just say that x is equal to the natural log of 0.6402. Grab your calculator out, punch it in, and you should get, therefore, x is equal to negative 0.4460. And that, right here, is our final answer. When we're given exponential equations that don't have the same base, then you need to solve using this technique. First, you're going to take the natural log of both sides, and then you're going to use the properties of logarithms to solve from there. So it just depends on which property you're going to apply based on the problem at hand. Problem 7. The first thing I want to do is take the natural log of both sides. So I'm going to say the natural log of 8 to the x is equal to the natural log of 21. I've done the same thing to both sides, so I'm keeping the equations equal. That was step 1. Step 2, we're going to apply the power rule. So we're going to have x natural log of 8 is equal to the natural log of 21. Step 3, solve for x. In order to solve for x, let me just write this down again. I'm going to divide both sides through by the natural log of 8. What I do to one side, I must do to the other, and that crosses out. Therefore, I have x is equal to the natural log of 21 divided by the natural log of 8. It's just a number. Grab your calculator, punch it in your calculator, and see what you get. Hopefully, you got 1.46. If you got this correct, send the code word blueberry to your UWF instructor. If you did not get the word, or I'm sorry, the problem correct on that last bit with your calculator, send the code word blue. Problem 8. Problem 8 and problem 9 are a little bit more complex. I would expect you to definitely see something along the lines of the complexity of problem 8 and 9 on your next exam, just kind of giving you a heads up of the level of difficulty that's normally expected on your exam. So we have problem 8 here. We're going to take the natural log of both sides. So I'm going to have the natural log of 7x plus 3 is equal to the natural log of 9 to the negative 5x. Take the natural log of both sides. Step 1. Step 2, apply the power rule. Our exponent here is fairly long. It's still an exponent. So we're going to bring that down out front. X plus 3 times the natural log of 7 is equal to negative 5x natural log of 9. I'm going to want to solve for x is step 3. Solve for x. I'm going to use the distributive property right here to distribute the x to the natural log of 7 and then the 3 to the natural log of 7. So I'm going to end up with x natural log of 7, x times the natural log of 7, plus 3 times the natural log of 7, 3 natural log of 7 is equal to negative 5x natural log of 9. Notice that I have an x here and I have an x here. I need to get this term to the left side of the equation, and because this doesn't have an x, I need to get this to the right side of the equation. I'm going to do this through subtraction and this through addition. So I'm going to add plus 5x natural log of 9 to both sides. I'm going to subtract 3 natural log of 7 from both sides. Now I add straight down. So I have x natural log of 7 plus 5x natural log of 9. This right here goes to 0, is equal to, this goes to 0, and then minus 3 natural log of 7. So that's x natural log of 7 plus 5x natural log of 9 is equal to negative 3 natural log of 7. Okay, now you can see that we have x on each part here as a common factor. On each side of the plus sign, I have an x and an x. So I can factor that out. So I have x times the natural log of 7 plus 5 natural log of 9. And that's going to equal to negative 3 natural log of 7. The x is connected to this number through multiplication, so I'm going to use division to separate and solve for x. So I'm going to divide through by natural log of 7 plus 5 natural log of 9. What I do to one side, I must do to the other side. Therefore, x is equal to negative 3 natural log of 7 divided by the natural log of 7 plus 5 natural log of 9. You cannot simplify this out. Don't even think about going there. Instead, just grab your calculator and make sure you use parentheses here and here to put this in your calculator, okay? And punch it in and see what number you get out as your solution. I'm going to write over here, if you have the TI-30XA, the instructions for putting this in your calculator. So for the TI-30XA, here's your instructions. 7 natural log, that takes the natural log of 7, multiply by 3, and then you have to do the change of sign button, which is this button down. It looks kind of like this right here. Okay, it's next to your equal sign to the left of it. So you're going to hit that. Then you're going to hit your equal sign. No, don't hit anything. I guess you tap it. Then divide. I'm going to come down here. Parentheses 7 natural log plus, open another set of parentheses, 9 natural log times 5, close parentheses, equal sign. If you do these steps in your TI 30xa, you should get, as your numeric answer, negative 0.45 for x. Okay? Either way, you should make sure for your calculator that you get negative 0.45. Let's look at problem 9 here. Notice we don't have the same base. Since we don't have common base, we're going to take the natural log of both sides. So that's going to be the natural log of 5 2x minus 3 is equal to the natural log of 8x plus 1. Now we're going to apply the power rule. So step 1, take the natural log of each side. Step 2, power rule. Bring the exponents down out front. So that's 2x minus 3 times the natural log of 5 is equal to x plus 1 times the natural log of 8. I switched pens a little bit, and as you can see, it's a little shaky. I apologize for that. Hopefully that'll settle out. Now we're going to solve for x, step 3, and we're going to use the distributive property to distribute each part of the factors times the natural log part. So 2x times the natural log of 5. 2x natural log of 5. Negative 3 times the natural log of 5 minus 3 natural log of 5 is equal to x times the natural log of 8 plus 1 times the natural log of 8 is just plus natural log of 8. Don't need to write the 1 down, do we? Now we need to get all the x's on the left-hand side of this equal sign and everything else on the right-hand side. So I have an x over here. I need to bring it over here. I don't have an x here, so that's going to come over here. So we're going to subtract x natural log of 8 from both sides. I'm going to add 3 natural log of 5 to both sides. And I'm going to add going straight down. 2x natural log of 5 minus x natural log of 8. 2x natural log of 5 minus x natural log of 8. Negative 3 or minus 3 natural log of 5 plus 3 natural log of 5, that goes to 0. Bring down our equal sign. This part right here goes to 0. X natural log of 8 minus x natural log of 8 equals 0. And then I have natural log of 8 plus 3 natural log of 5. So far, so good? Now, notice right here on this side of the subtraction sign and on this side, I have an x. So I can factor that x out of both sides. So now I have x times 2 natural log of 5. That's what's left over here. Subtract natural log of 8. That's going to equal, just rewrite this over here, which is natural log of 8 plus 3 natural log of 5. Now my x is connected to everything over here through multiplication, so I'm going to use division to separate it. So what I do to one side of the equation, I do to the other side of the equation. I'm going to divide both sides through by the natural log of 5 minus natural log of 8. 2 natural log of 5 minus natural log of 8. And that goes away. All I have left over here now is the x. So I'm going to have therefore x is equal to natural log of 8 plus 3 natural log of 5 divided by 2 natural log of 5 minus natural log of 8. Put this in your calculator, and while you put this in your calculator, I'm going to write down the directions for how you would put it in the TI 30XA. So for the TI 30XA, you're going to do the following operation. You're going to open up with a parentheses. You're going to do 8 natural log plus 3 multiplied 5 natural log. Close parentheses. Hit the divide button. Open parentheses. 2 multiplied by 5 natural log. Subtract 8 natural log parentheses equals. Okay, so the final answer is right here. Therefore, x is equal to 6.0624. So if you've put this in your calculator, it will equal 6.0624. And if you were able to do that on your calculator and accurately put that in your calculator, send us the code word chocolate chip. Chocolate chips, okay? If you tried but you weren't able to get it quite right, keep working at it. Don't give up. You've got to figure it out. If you need help, just reach out to your instructor. That's what we're here for. We're here to help you. Or reach out to YouTube on how you use your calculator. But if you tried but you didn't get it right, send us the code word lemon bars. Next problem. It's going to be a little bit hard to read through here because I wrote into here, and I'm sorry about that. Logarithmic equation. It says the solution must satisfy the domain of the logarithm. Very important that you remember this. On your exam, you must take and analyze your answers compared to the domain to make sure that the solutions are actually in your domain. It's very common for you to get an extraneous, which means an extra solution that's not in your domain, therefore it's not a real solution. Recall that x has to be greater than 0 is the domain for our log. Another condition is that a has to be positive. So we're going to have to look at both of those situations. So it says find the domain for part 10. We have to have 4 has to be positive, which it is, and then the domain part we're going to look at is for the x. So for our domain, we have to say that x minus 1 has to be greater than 0. It can't even equal 0. It has to be greater than 0. So we'll add 1 to both sides. And this says that x has to be greater than 1. So that is our domain for this problem. So our domain is going to be from 1 to positive infinity. This is a parentheses. This is a parentheses. Both are going to be parentheses because we can't equal 1 and we can't equal positive infinity. Looking at problem 11. Problem 11, we have 2 areas to consider. We're taking the log of 2 different areas. So we have to say that x plus 3 has to be greater than 0. And 2 minus x has to be greater than 0. And we need to solve each of those statements. This one here is more simplistic. We can just subtract 3 from both sides and we get x has to be greater than negative 3. This one right here, if I subtract 2 from both sides, I get negative x is greater than negative 2. Well, I haven't solved for x, have I? What I solved for was a negative x. I have to solve for positive x. I'm going to multiply both sides then by negative 1. What I do to one side, I do to the other. And it's very important that you remember when I multiply or I divide through by a negative, that I have to flip my sign. So a negative 1 times a negative x gives me a positive x. Because I multiplied by a negative number, I flip my sign. Negative 2 times negative 1 is a positive 2. So here's my boundaries. It says that x has to be greater than negative 3, but x also has to be less than positive 2. So let's draw a number line and look at this. Here's our number line, and I'm going to put negative 3 right here, 0, and then positive 2, positive 3 right over here. And according to the information that I obtained, the first one here, x is greater than negative 3. We're going to have an open circle right there because x has to be greater than negative 3, and we're going to be going to positive infinity. The next one here is x has to be less than 2. Here's 2. So at 2, we're putting an open circle, and then we're going to negative infinity. Our domain is the area in common. It is the intersection of the two. So as you can see, our domain is going to be from this spot right here, from -3 with an open circle, to 2 right in here. So this is our domain area right in here. That is our domain. So our domain is going to be from -3 to +2. And that is it. And that's our answer. Moving along to our next concept. Solving logarithmic equations. You may have to use the properties for logarithms and then use either the exponential form or our property that's of conversion from log base a of x equals log base a of y, which then means x must equal y, because we're taking the log base a of the same thing. So either one of those we're going to have to use. Let's look at the very first one, problem 12. So problem 12 says we have log base 4 of x equals 2. Well, let's rewrite this as an exponent. And when we do that, we get 4 squared equals x. 4 squared equals x. Well, what's 4 squared? It's 16. Therefore, x equals 16. Done. What do you think? Let's identify our domain. For this particular problem, our domain is from 0 to positive infinity. I don't have any shifting here, so it's from 0 to positive infinity. Let's look at 13. Okay, so we're going to solve problem 13 next. In problem 13, first just convert this to an exponential, because I have a base that's a number and a number over here. So when you have a base that's a number and a number over here, that's kind of a clue to go ahead and set it equal, or rewrite it rather, as an exponential. So this is going to be 6 cubed is equal to 5 plus x. 6 cubed equals 5 plus x. Well, grab out your calculator. What is 6 cubed equal to? Very good. 216. So 216 equals 5 plus x. This is just a number. Convert it to the number. This is a regular algebraic equation. We're just solving for x. We'll subtract 5 from both sides, and we end up with 211 is equal to x. Therefore, x equals 211. The next thing we do before we declare that we actually have the answer is we have to look at the domain. Okay? Our domain is such that 5 plus x has to be positive. 5 plus x has to be greater than 0. Subtract 5 from both sides, and we get x has to be greater than -5. Is 211 greater than -5? Yes, it is. Therefore, x equals 211 is indeed a valid solution. Our domain will write it as -5 to positive infinity. But that is a solution. Let's look at problem 14 next. The first thing I want to do is actually bring this 2 over to the 1. So I'm going to subtract 2 from both sides and add going straight down. So 2 plus -2 is 0. Log of x is just log of x. 1 plus -2 is -1. Now I'm going to rewrite this, because this is really base 10, right? That's all that is. So I have a base that's a number over here. Remember what I said. When you have a base that's a number and a number over here, no variables, this is a perfect time to write it as an exponential. So this is 10 to the negative 1. 10 to the negative 1 is equal to x. Well, let's rewrite 10 to the negative 1 as just 1/10, right? That means I have to move the 10 to the denominator. So x equals 1/10. But we're not done yet. We have to compare this to our domain. Okay, our domain is, we don't have any shifting going on here, so our domain is going to be from 0 to positive infinity. Since x equals 1/10 is in the domain, we know that this is a valid solution. Let's look at number 15. We have the natural log of 5x plus 4 equals 3. Remember that the natural log is just another way of writing log base e. So we can go base e of 5x plus 4 is equal to 3. Remember, e is just a number. So I have a number that's a base, and I have a number over here, no variables. That tells me I can rewrite this as an exponential. So I'm going to have e to the 3 is equal to 5x plus 4. This is just a number. Grab your calculator, put it in your calculator of how you would calculate 3 raised to the e, and you're going to find out that it is 20.0855554. I like to go out to at least 4 or 5 decimal places for accuracy. So again, on the TI 30XA, so the TI 30XA, e cubed is going to be equal to, you're going to do the following, okay? You're going to put in 3, then you're going to hit your second button, then you're going to hit your LN button. LN button. And that's all you have to do. You don't have to hit equals or enter or anything of that nature. And you will see that it gives you 20.08554. So now that we know that that's what e cubed is equal to, we can set that equal to 5x plus 4. We're solving for x, so we'll subtract 4 from both sides. And so minus 4 is equal to 16.08554 is equal to 5x. We're solving for x, so we're going to divide both sides through by 5. So hit divide by 5, and I get therefore x is equal to 3.217. Now I have to compare this to the domain. Is this in the domain? That's my next question. Every single problem on your exam, compare your answer to the domain. I promise you, well, I don't promise you because I'm not making the exam. But based on my years of experience, the person who makes the exam typically puts 1 to 2 problems on the exam where you will end up with 2 solutions, of which one is extraneous. In other words, it's not a valid solution because it's not in the domain. So just get in the habit of always checking your solutions to make sure they're in the domain. So once you have that habit established, it's second nature. On your exam, you'll do it for all the problems, and you'll find those ones that have an extraneous solution. So here, we're going to have to say 5x plus 4 has to be positive, has to be greater than 0. So we can subtract 4 from both sides, and we get 5x has to be greater than negative 4. Divide both sides through by 5, and we get therefore x has to be greater than negative 4/5. Negative 4/5 is negative 0.8. So my domain is going to be from negative 0.8 to positive infinity. Positive 3.217 is greater than negative 0.8. So we know that this is a good solution. It is in the domain. Let's look at problem 16. Here we go again. We have to recognize what we're being given and what we're being asked to do. We're being asked to solve for x. Notice that right here we have a plus sign. Remember before we could have two factors, if we have the same base, which we do, with a plus sign, means that I can rewrite this as log base 2, factor 1, 2x minus 5, multiplied by factor 2, x minus 3, equals 3. Remember, we can just rewrite this and put these factors together with multiplication. Notice I have a base that's a number, and I have an answer over here that's a number. I have two numbers. That means I can rewrite it as an exponential. So now I can go 2 cubed. So 2 cubed is equal to 2x minus 5 times x minus 3. Well, we can solve this because 2 cubed is simply 8. So 8 is equal to 2x minus 5 times x minus 3. We're going to use the distributive property or FOIL and rewrite this as 2x times x, 2x squared. 2x times negative 3, negative 6x. Negative 5 times x, negative 5x. Negative times a negative gives me a positive 15. Now I'm going to combine like terms. 8 is equal to 2x squared. Negative 6x minus 6x is negative 11x plus 15. Now I can bring that right up here and keep solving it. We're going to bring our 8 over. So this is going to give me 2x squared minus 11x. 15 minus 8 is 7. So plus 7. That's my quadratic equation. Now, I'm not on an exam. I don't necessarily recommend always, unless it just jumps out at you that it factors, I would just say go ahead and do the quadratic formula. So my A is equal to 2. My B is equal to negative 11. My C is equal to 7. Make sure you have your quadratic formula memorized. If you haven't memorized it yet, this is an excellent time to memorize it. I'm writing it down here for you, just in case you don't have it memorized. There you go. That's the quadratic formula. Please memorize that before this exam and before the final exam. Okay, so continuing to solve this, it's going to look like this. X is going to equal to minus b. B is equal to negative 11, and negative times the negative gives me a positive 11, okay? Plus or minus the square root. B squared, that's 121, minus 4 times A times C, all over 2A, which is going to be 4. Therefore, X is going to be equal to 11 plus or minus the square root of 65 divided by 4. And that's going to equal my lower number. The lower number that it could equal is 0.73. 0.73. The higher number that it can equal is 4.77. What that means is I have a positive and a negative right there. So if I go 11 minus the square root of 65 divided by 4, that's going to equal to 0.73. If I take 11 plus the square root of 65 divided by 4, that's going to equal to 4.77. Those are my two values that X can equal. And actually what I might do is go ahead and change this to brackets, because I think I would like that better. Okay, so X can equal either one of those two values. Now I have to compare those values with the domain. So we're going to come in here and I'm going to say, what is the domain for this problem? Okay, my domain. I have to have 2x minus 5 has to be greater or equal to 0. 2x minus 5 has to be greater than 0, not greater or equal to, just greater than. So this is going to be 2x has to be greater than 5. Divide both sides through by 2. Therefore, x has to be greater than 5 halves. That's the first part. I also have to look at this part right here, x minus 3. So x minus 3 also has to be greater than 0. So x has to be greater than positive 3. Which one is more restrictive? This is really 2.5. This is 3. So this one here is more restrictive. So my domain for this problem is that x has to be greater than 3 to positive infinity. So when we look at that, let's look at these numbers here. 0.73 is not in the domain, is it? But 4.77 is. So our only valid answer is 4.77. So our answer is going to be, therefore, x equals 4.77. And that is our answer right there. Because we had to take our solutions, compare it to the domain. 0.73 is not in our domain. Therefore, it is not a valid solution. It's an extraneous solution. Please make sure you remember to check for those on your exam. Let's move on to problem 17. Problem 17, we're going to approach the exact same way. You see that plus sign right there? We have the same base. It's all base 10. So we're going to say, I can put those together on the left-hand side. So I can rewrite this as log of 2x plus 1 x is equal to log of x plus 8. Okay? Now, when I have the log of one side is equal to the log of the other, that's just like saying I have the same base a to the x equals the same base y, therefore x equals y. Applying the exact same principle right here, if I'm taking the log base 10 over here, the log base 10 over here, I can say 2x plus 1 times x is equal to x plus 8. I can simply remove the logs and now I can solve. I'll distribute my x to each term in here and get 2x squared plus x is equal to x plus 8. Now I'm going to bring all of my terms over here to the left, so I'll subtract x from both sides and I will subtract 8 from both sides. And I will get 2x squared, those will go to 0, minus 8 equals 0. Now I can factor out a 2 because a 2 is common to both sides. So this is going to be 2 times x squared minus 4 equals 0. Do you recognize this? It's a difference of 2 squares. So now this is going to be 2 times x plus 2 times x minus 2, and that all equals 0. We can set our factors equal to 0 and then solve for x, or you can just simply say I can see that x is going to be equal to negative 2 and positive 2. So plus and minus 2. Now, are they both in my domain? Let's look at the domain. My domain says that 2x plus 1, 2x plus 1 has to be greater than 0. X has to be greater than 0. And then x plus 8 has to be greater than 0. All three of these statements from here, here, and here have to be true. So rewriting this one here, we would subtract 1 and then divide through by 2. So this is going to give us x has to be greater than negative 1/2. Right here, it's already done for us. X has to be greater than 0. And this one here is x has to be greater than negative 8. Now I need to see which one is most restrictive. The most restrictive one is x has to be greater than 0. I have to look at where all three of them are in common, okay? I have to look at where all three of them are in common, and that's going to be at x is greater than 0. So my domain is 0 to positive infinity. I now have to compare over here, and I can say, therefore, x is equal to positive 2 is our only solution. X cannot equal negative 2 because it's not in the domain. My only solution is x equals 0. Let's look at number 18, our last problem for the day. Here we go. I want you to notice that we have the natural log of x plus 6. It's a factor. Subtract natural log of x plus 2, another factor. Since I have a subtraction sign, I know I can combine those factors through division. And then on the right-hand side, I have the natural log of x. So I'm going to rewrite this as the natural log x plus 6 divided by x plus 2 is equal to the natural log of x. I'm taking the natural log of both sides. Because of that, I can simply say that x plus 2 divided by, let's try x plus 6 divided by x plus 2 is equal to x. I'm going to solve this all the way through, but if you want to, feel free to pause this, solve it all the way through, check your answer against the domain because this is our last opportunity, and then push play to see if you got the right answer. I'll see you back in just a minute. Okay, in this case, I'm going to multiply both sides through by x minus, or x plus 2 rather, because what I do to one side, I have to do to the other side. And those are going to be factored out right there. So on the left-hand side, I have x plus 6 is equal to x times x, x squared, x times 2x plus 2x. Now we want to bring our x plus 6 over to the right because I need my x squared to have a positive coefficient. So I'm going to subtract x, subtract 6. What I do to one side, I do to the other side. Add straight down, I get 0 on the left, and on the right I get x squared plus 1x minus 6. Now I can factor this, okay? So now we're going to factor this to solve for x because our objective is find all the values of x to make this a true statement. So when I factor, let me draw a little line here so that we know the prior problem compared to the current problem. So when I factor, I'm going to put an x here, I have a 6, which is going to be a 2 and a 3, and I have a negative sign right here with a positive sign in the center. So I'm going to have opposite signs. The larger of my two factors, which is 3, is going to be positive. My smaller is going to be negative. So now when I double check, I get x squared minus 2x plus 3x. That gives me 1x minus 6. So those are my factors. I'm going to set each factor equal to 0 to solve for x. So it's x plus 3 equals 0, x minus 2 equals 0. Therefore, x equals negative 3 and x equals 2. Now what I want to do is to compare this to the domain. My domain. It's always good to probably look at your domain first. I'm in the habit of looking at it last. I'm not sure why that is. Probably not the best habit. Okay, so we're looking at our domain, and our domain is that x plus 6 has to be greater than 0. X plus 2 has to be greater than 0. X has to be greater than 0. I looked at all 3 sections right here. So this means that x has to be greater than negative 6, x has to be greater than negative 2, and x has to be greater than 0. This one right here is the most restrictive. So my domain is going to be from 0 to positive infinity. Looking at both of my answers here, you're going to notice that this one right here does not qualify because negative 3 is not greater than 0. So my only solution that I have is indeed x equals 2. So that is my solution. And this one here is not my solution. If you got this all the way correct, wow, I'm so proud of you because this was a tough problem. Send me the code word horse. And if you gave it the good old college try, but you didn't quite make it, then please send me the code word cow. And since you made it to the end of the video, let's have you send another code word, and that code word is going to be ba black sheep. Since we're doing cows and horses, let's just keep it in the family of livestock. So our code word for the fact that you made it to the end of the video is going to be ba black sheep. And I hope you all enjoyed today's lesson. If you have any questions, just reach out to your UWF instructor. He or she will be happy to help you, and we're so thankful that you took and watched the video. Take care, have a great day, and we'll see you again at our next lesson.